A year ago, I was invited to a kind of special conference that was designed for kids and teachers, especially in secondary school. So they were like pretty much teenagers. And I was supposed to talk about how to safely use the internet, like what to do, what not to do. And it was like in a place quite similar to this. And I was starting my amazing speech, my amazing talk. So most of the kids were like staring at their phones. They were like looking downward in this like massive 45-degree angle. Their faces were mysteriously lit up by the screen. So you guys can imagine what it could be like to give a speech to this kind of audience. And I stopped and I said, hey guys, I mean, am I being annoying you, or am I being disturbing, or what? And one of the kids looked up and he told me this, like, dude, like this is like boring stuff you're talking about. So the thing is, the only thing that is really interesting for us from a programming or ID point of view is like game cheats. That's pretty much they were all interested in. At least that's what they told me. So said, okay, why not? Let's talk about game cheats. And from then on, they put on their phones, and we started to have like a really good discussion. And that was like an interesting lesson for me. First of all, writing cheats must be sexy, because teenager kids are really interested in that. And on the other hand, writing cheats and dealing with cheats and working with application cheats or game cheats is a really cool thing to introduce people into, to hook them into writing programs and hook them into writing applications. And that was a really interesting theory for me. And as I was talking to some other people, as it turned out, this is like a really interesting topic. Like we had some meetups which were dealing with applications and game cheats, and they were really popular. So we're going to talk about writing cheats, especially for Android applications. So just a quick who am I? My name is Zsombor, Kovacs. I work currently as a researcher for MLG Effitas. In my spare time, I waste too many hours trying to break Android applications. And I'm also a founder of Hacktivity. And this is a really nice opportunity to give you guys an introduction into how to write game cheats and how to get started in this topic. So before we get started, let's talk a little bit about how an Android application is built up. So we have the application itself. So at the first glance, we have a local device which runs the application code. We have some network endpoint, and there must be some connection between the network endpoint and the application code itself. Of course, we have a piece of hardware running like cameras, GPS equipment, the screen itself, sound cards, gyroscopes, whatever, which must be also being in interaction with the application code. We have some local files. We have some interactions with local files. So that's pretty much the basic idea how an Android application is supposed to be working. But let's dig a little bit deeper into how that thing works and how that can be used to write cheats. So let's get back to square one. We have the code. We have a device. We have some network endpoints. We have a piece of hardware. We have some local files. But that's not all. We have something that is called the runtime environment. And this is like the service that the operating system provides to the application itself to get access to all the goodies in the previous slides. So hardware is reached through these runtime environment details. It also handles the local files. It also has API calls to call other endpoints, other network servers. And basically, this is how Android applications work in the first place. And as you will see, the methods I show you guys here they can be used to hack all sorts of applications, not only games. All right, so how do we attack? So what should we do with this kind of application layout? So first of all, where can we attack? Of course, we can go for the network stream, so we can do man-in-the-middle attacks. We have a lot of cool tools to do that. That can be done quite easily. Of course, if we have some SSL countermeasures like certificate pinning and that kind of stuff, that can make our job much harder. But nevertheless, we can overcome those problems. Also, we can attack the application code itself. We take a hex editor or just use IDEPRO or some other binary tweaking tool to patch the application code itself, and we can change the application's behavior. We can also tweak the local files within the file system. So when it comes to Android applications, this usually involves changing files in the sandbox. We also can use the hardware, so we can mock things. We can spoof our GPS location, or we can, as we saw yesterday, we can use a GPS jammer to go wherever we want on the world. We also can attack the network endpoint if we're allowed to do so, but in most cases, that option is off the table. And finally, which I will show you and which we will be using in the next few demos, we can also change the runtime. We can tweak with the runtime, which surrounds the application code, and that's responsible for every interaction of the application. All right, so how can we do that? And why would we do that? So runtime environment manipulation comes with a whole lot of benefits. First of all, we can intercept and change application calls, so we can change the way the application interacts with its environments, and we can also change how the application functions internally. So what this basically means that we can take any object, if we consider a Java application, we can take any class within the memory, and we can change what it does, how it does it, and basically we can hijack the entire operation flow of the application. We can overwrite methods, and then, which is a really nice touch, we can just quit our tool, and the application will return to its normal state of operation, which we will see that it's not something that every tool provides for us. So how can we move on? So what are the tools we can use to tamper with the runtime? So I will show you 3 tools to do that. The first one is the exposed framework. I'm pretty sure that you guys, for those veterans who have been using Android since its inception, many of the security features which are now built into Android, they used to be available only for rooted devices through the use of exposed framework back in the old KitKat Marshmallow days. For instance, in those days, you were not able to change which application has access to which permissions. So for instance, if you installed like Facebook or Facebook Messenger, and it wanted to have access to, for say, the GPS coordinates, you had no chance to revoke it later on. So once when you installed the application, it was there forever. So, but later on, Google changed this permission model with 6.0. Now it's a feature built in the operating system. But back in the days, you had to use the X privacy framework. I'm not sure if that rings any bells to you guys, but that was an extension to this exposed framework. So exposed had like a module repository which contained modules for literally everything from bypassing root detection, bypassing certificate pinning, all sorts of stuff. The other tool is called the CTS substrate. Those folks who have been using jailbroken iPhones back in the day, I'm pretty sure you guys know this term. This is the same guy, and it basically does the same thing. So it's a runtime environment manipulation framework. And unfortunately, it's now abandoned as far as I know. So the latest supported version is KitKat. So it doesn't work on recent Android devices. But we have something way, way, way better. It's called Frida. As I was told, it's a Norwegian project. And that's the correct way of pronouncing the name. So this framework is really, really cool. I mean, it does everything we need to do, as you will see it later on. So it's perfect for penetration testers. So for you folks out there who have to spend their time testing e-banking Android or mobile banking Android applications, this is one of the coolest things you can get in your arsenal. So basically what it does, it gives you a scriptable, quite easily scriptable framework for application manipulation and a nice API to do so. And what last but not least, it's rock solid in terms of it never crashed. Like seriously, I've been using Frida for a long time and it never once crashed. I mean, sometimes the application crashed, of course, but that was because of me writing the wrong hooks, and eventually it caused some kind of exception what the application was not able to handle. So basically, that's Frida for me. OK, let's see how we work with Frida. A typical workflow is like we have an APK, an Android application, either from the App Store or from wherever else, from, let's say, this is like a pen testing assignment, and the client gave us the application installer. So first of all, we need to get access to the code itself. So we decompile the application. I will show you a couple of tools which is capable of doing that. And then we have to dig through the code and to find our way around and to see which are the methods and which are the classes which are crucial from a security point of view and which are interesting for us. And then we create a little Frida script to tweak with those objects and those classes. And then we marry those things, the application and the Frida script itself, and then we see the change in the application's behavior. How can we get around our way through the first step, which how can we decompile an application? So there are many ways we can do that. So the basic idea of application decompilation is to have an approximation of the actual Java code which was used to build the application. So we can use a couple of tools to do that. First of all, we have Dex2Jar. That's a quite old project. It's available on Google Code. And that translates an APK file to a jar file, which can be subsequently torn apart using your favorite Java decompiler tool, like JDGUI, JODEX, or whichever tool you want. But fortunately, you don't have to have those tools on your computer permanently, because there are a couple of websites which provide you this service for free. So this means that you just simply upload your APK file to that web page, and it, in return, returns you a decompiled Java source in a nice zip file. So it's quite easy to get through this step. OK, let's see how Frida works. So we have the application code and the local device, which is running Frida server. In order to inject our hook into Frida, we have to have a Frida client running on our machine. So most of the time, this means that the Frida server can interact with the runtime, and it can tweak whatever we want. All right, so how do we do that? Come on. OK, so let's see a couple of templates for our later tweaks. So this will be really interesting. And this is quite cool, because I didn't really find such a compilation of typical Frida templates on the web. So first of all, if we want to tweak with a method, let's say we have a class which is called main activity here, and we have a method here which takes two parameters, like two strings here. How do we want, if we want to change this method, we apply the following Frida code. So basically, the whole point is this is like a template thing. So we include the name of the object itself, which is called this package name .main activity, and we can overwrite the implementation of the method using this construct called act.method.implementation. And then we take two parameters, we do whatever we want, and we can then return either the original value with this .method construct, or we can return true or false, because as we see, this in our example is a Boolean method. So this method returns a Boolean value. So if we don't want to break the application flow, we also have to return a Boolean value. All right, let's move on. What if we just simply, we don't want to change the application's behavior, but we want to tweak and to look into the application itself, to dump the, for instance, dump some kind of value which is in a variable within an object. So let's say that we have here a myObject object which has a string array which is called A. In order to get access to this secret parameter, we use this kind of Frida script. So we simply take, we look for the myObject object in the memory, and once we found that instance, we take the value of its secret parameter and we just dump it. So that's pretty easy. It doesn't really change the application flow. It doesn't do anything to the objects themselves. It doesn't replace anything. It just simply dumps whatever we have within the object itself. This is cool, right? But what if we have, which is like a common scenario when it comes to decompiled Android source. So most applications which come from the App Store, they go through some form of obfuscation. So most of the time, this means that the ProGuard rules are enabled within Android Studio, and that mangles the classes and method names within the application source. So even if you decompile the source itself, you won't be able to figure out what the application's methods and objects do, because their names will be reduced to like letters like A or B or like AA or anything like. So you guys kind of get the idea. So Java allows a developer to use the same name for a variable and for a function, because the signature will be still different for those two. And in order to get around that problem, let's say we have this secret parameter here, and also we have a function which is called A. In order to get around this problem, we use a similar solution in Frida, but we have to use an underscore prepended to the variable name. Okay, enough of code. Let's create some cheats. All right. So how do we get started? First of all, First of all, we need to start Frida. So first of all, I come to my device. If you look at the Frida website, you can find distributions to and servers to many platforms, for instance, like iOS, Android, Linux, whatever. And you have to download the corresponding version, a corresponding architecture to your device. I'm using Android x86 here, so I started Frida server. Okay, so just to check that Frida is working, Frida PS gives us a list of the processes which can be tweaked using the USB connection, hence the -U switch after Frida. Okay, so let's see the first thing. So now we see that all the applications and all the environment is working fine. Let's see. So I start to type in some stuff, and I tap on encrypt, and apparently the application encrypts whatever I have. This is interesting. And the task is to find out what the key is. So how can we do that? The first approach like let's call it the traditional approach, is that we simply take the application, we tear it apart, and we try to figure out what the encryption key is. So I see that this is kind of a static key. So if I press encrypt again, it returns the same output for the same plain text value. So this concludes that it's a static key. It's using some kind of static key. This is the actual piece of code that is responsible for encryption. So it's not very hard to understand how it works. So once you have two string values, two string parameters, it defines an AES ECB cipher with PKCS5 padding. And what it simply does, it takes the value, the plaintext, and it encrypts the whole thing with the first parameter and returns that as a string value. So that's not really hard to follow. So in order to find out what the key is, we simply use this Frida function. We take the main activity parameter, which is enclosing this encrypt function, and we replace the implementation of this encrypt function with one that before executing the actual encryption feature, it logs everything to the console. So let's see how it works out. So how we invoke Frida is we simply provide the process name which we want to hook using this set of processes. And we also need to provide the JavaScript file which contains the code of the actual hook. That's what I showed you guys here. So this is the actual contents of that JavaScript file. So we started that. And if we click on encrypt, we see that the encryption key is written out on the screen along with the ciphertext, which is kind of cool because we didn't have to touch anything within the application. I didn't have to resign it, didn't have to patch it, didn't have to do anything with it, which could break its internal integrity check controls, which is kind of cool. Okay, so we are almost as cool as Tom Cruise using this Kawasaki motorcycle. Okay, let's move on to something more interesting. Our second application is a kind of it's a login application. So I enter something here, and the application returns incorrect credentials entered. So obviously there's some kind of local PIN screen, which can be quite often seen in thick client applications or mobile banking applications. And it stands to reason that we should find out how to get our way around this. If we come back to the Prezo, this is the actual code that is responsible for the application login logic. So as we see, there's a click listener which is associated to this login button, and it invokes a Boolean isPinCorrect function, which takes the string as a parameter. And it does something which is irrelevant for us at this point, and returns a Boolean true or false. So let's find out how we can bypass this. Obviously, we could use the same method as earlier, so that the application is changed so that it always returns true, so that we can basically bypass the login screen. But I found something way cooler than that. So let's see if we can brute force the code. So what we do is we locate this class in the memory, this object in the memory, and we start iterating a potential key space of potential pins. And should the isPinCorrect function return a true value, then we log it out on the screen, and we know that it's been the correct pin. Okay, let's have a run at it. And as it turns out, It's quite quick. 10,000 is a really small key space. And as we see that the correct answer is 8646, which is true. And this is quite cool because in order to brute force this pin, the actual way of how the pin is checked is completely irrelevant from my point of view, because I used the very same method call which the application uses. So this is quite cool because I didn't have to reverse engineer whichever intricate encryption method the developers happen to implement within their code. I don't care. I don't have to know, because manipulating the runtime and manipulating the application, I can use the very same implementation of the piece of code. So this makes things way, way quicker than trying to reverse engineer the crypto of the application itself. OK, scenario number 3. Oh, we also this cool. Android applications have a tendency to detect rooted applications. Of course, there is a whole bunch of tools around that. Many of those tools involve, for instance, the exposed framework. I think root clock is the application or the exposed module which you want to use should you want to bypass traditional root detection methods. But we can do that by hand. I can show you 2 demos which are supposed to show how root detection bypass can be done. OK, let's see my demo application, which is quite a crude one. So when I press check, and it responds back that my device is dirty, so it's rooted. So how can we get our way around that? We take the application. We simply look at what the application does when we press this button. And as we see, that the logic is very similar to the previous example. So this means that there is a Boolean returning function, which I dubbed is rooted, but it can be anything. And should the application detect a rooted device, it returns with a true, otherwise it returns a false. So it's quite trivial what it does. So what we do is simply take the implementation of that method, and we simply overload it with our custom code. And we always return false in this example. And let's see how it works. Again, I use the same method as earlier. If I click here, then we have a root detection invoked message as we asked, and boom, the device detects it's clean. See, it's quite boring, and it looks quite trivial. I mean, like, come on, who would do such a very trivial to bypass method of root detection? I show you these guys. So when we click here, said, no, sorry, you can't use our application on a rooted device. But how can we get our way around that using the exact same method? I obviously won't show the code to you guys. I hope you understand. All right, if we go here, click, and then we can move on. All right. Now let's have some fun. I won't show you. Tom Cruise obviously has a tendency to do all sorts of crazy stunts with motorcycles without any proper protective equipment. Kids, this is not cool. All right. Let's have some fun. So let's do. I promised you guys a cheater for a Minesweeper game. This is our favorite Minesweeper game. It's apparently quite similar to all Minesweeper implementations. So how cool it would be to know where the mines are. This is also possible with Frida. If you want to find out how to reproduce this kind of hack, you're supposed to find like a two-dimensional array in the memory, because most Minesweeper applications have a tendency to have only one or two two-dimensional arrays, and those are responsible for the table itself. So let's see how they work. OK, and now that we see that this is the table, so this is supposed to be mine here. Yep. And you see, it's basically the same stuff. So the really cool thing about these hacks is that you don't really have to spend too much time on trying to figure out how to do stuff. I mean, these hacks can be developed in quite literally like a couple of hours. So no hard programming skills are required. So that's if you happen to have a kid who wants to get into developing game cheats, Frida is the go-to solution for those. All right, let's see what I know. OK, and now let's have a cheater for a blackjack game. This one was really, really fun. So the game itself goes like this. I just downloaded it from Play Store. It's a free blackjack application. Fortunately, it doesn't allow you to earn money, so it's not connected to anything. It works pretty OK in every environment. So as you can see, I must be pretty good at this game, as I have 1.23 quintillion of whatever currency the game happens to be using. And OK, let's see. Let's play something. Let's see how it works. It's like a quite traditional game of blackjack, so I'm pretty sure you guys know the rules. But how cool it would be if we could have access to the deck itself. Let's see how we can get around that problem. How do you call it? Two. OK. So what this Frida script does, it finds the deck object within the memory, and it just enumerates it. So now we see that there must be something dodgy going on, as we have two tens of dames right after one after another. If I say let's deal, I'm supposed to have a 10 and an ace, and I'm supposed to have a blackjack, boom. But it was not me. I'm serious. OK, let's try another one. This was completely accidental. I was not supposed to have a blackjack yet. OK, now I should have a dame and an 8. OK, see, I'm not winning at this point. Come on. OK, see, so this is quite cool because you can peek into the cards that are supposed to come. So this means that from now on, it's quite trivial to win. So that's quite kind of cool. But I was thinking, like, I made like several $1 trillion using this method. But it made me think that maybe we can do better than that. So how about like having a blackjack each and every time in my hand when I start a game? So that's also possible. I have a 2 version of this cheat. See, basically what it does, it simply substitutes the values of the deck object. So it's basically an array. And it substitutes the cards that are in the position of being handed to the player. And now I'm supposed to have a blackjack whenever I play it. So that's kind of cool, because I can win whenever I want. So from now on, this has completely changed the focus of the game. So what I was really interested in, how far can you get? Like, for the first time, I wanted to see what's the biggest chip in the game. Like, and it turns out this 1 billion is the biggest one the game has. But you see, this thing that I'm supposed to win all the time, this presented a problem, as you can't put all your money in the stack, as you have to press this 1 billion chip each and every time you want to enter 1 billion units to the stack, and it's quite boring, because I should, in order to put all this amount, I should press it 1 million times, which is kind of boring. So I came up with a little script that does this for me, which does, where is it? No. Let's say I want to put it like 500 times. And this made things way quicker. And then I have my nice cheat, which allows me to win. And I have my blackjack. Amazing. So at this point, we are this cool as Tom Cruise on this motorcycle, which this image is like brilliant, because it has everything that can be cool about an action movie, like a hero, explosions, pigeons, a motorcycle running away from the explosion, and cool sunglasses, leather jackets, and no safety equipment. All right, so that was all. Thank you for your attention. Another thing, so in order to, if we come back to my little game, so I was really interested in how far you can get with this. So at this point, I have 1.2 quintillion units. And the fact that the game is prepared for such a ridiculous amount of money, and the fact that it has the biggest chip the game has is 1 billion, whatever unit. So if like this is supposed to be like a real use case of a player reaching this amount of money with no cheats, or the game developers were prepared for cheating. So in order to put everything on the stack, you should click this many times on that billion chips. So this made me think this game, the developers of this game, they may or may not have been expecting some cheaters. Thank you.